Congruent shortcuts is all about, if two triangles are congruent, then what's true about all their sides? They're the same. And what's true about all their angles? They're the same. That's what congruent means, same size, and same shapes, but all their angles and all their sides are the same, right? Now, if you're working at the Ford factory, what's so funny? Why are you looking at me? Do I look like
It's a purple thing.
the purple thing? My pen blew up in mine. Okay. So anyway, if you're working like the Ford factory or something like that, or an assembly line, you don't want to, like, if you want a door for your Ford Explorer, whatever you own, right? You don't want to measure every single angle, right, and every single side, and every single hole in the Ford and all that, because there are certain shortcuts that you take. Well, if I know this side, and maybe this angle, that's enough to conclude that those are the same size and shape. You understand what I'm saying? So like with triangles, if I say, here's a triangle, I want to build another triangle just like that, okay? And so maybe you're working at the triangle factory to make it simplified a little bit. You don't want to, and okay, I want to order all my parts for my triangle from some specific factories, right? And so I don't want to. I say, okay, I need this side to be 10 inches, and I need this angle to be 40 degrees, and I need this side to be 9 inches. I need this side to be 7 inches, and I need this angle to be 80 degrees, and I need this angle to be 60 degrees. You don't want to go through and make all those measurements. So what congruence shortcuts is saying, are there 3 things or more maybe? You only really need 3 things. Which 3 things can I order at my triangle factory to make sure that I will have the same size and shape triangle? You understand what I'm saying? So some of the possibilities that you can have are a side. If you have the 3 sides, is that enough to ensure that this triangle will only make one specific triangle? You understand that idea? Or maybe I could have a side and a 40-degree angle on a side. Maybe that works. Maybe I can have 2 angles and a side, like that. Maybe I can have 2 sides and an angle. Maybe I could have just 3 angles. What else is there?
Could you have an angle, a side, and a side?
Or maybe I could have an angle, a side, and an angle. Could I have a what? Could I have an angle, a side, and a side?
You could.
You could, but that would be a bad word. So you can't have that. Okay?
Oh,
So,
what does it spell?
I don't know. So, you guys are so mature. All right. So anyway, in Sketchpad, they have this little investigation that shows you why those things, which ones work and which ones don't work. Okay, and I was going to take you to the computer lab, but what happens is people always get confused when I do this in the computer lab. And so I kind of want to do it for you. What? Where did it go? There it went. So I kind of want to do it for you. So here is it going to let me write on here? If I write on here, will it mess things up? There. Okay. So here's a triangle, and this is your original triangle. So what they do, if you click on SSS, it takes another triangle, okay, and it says, is there more than one triangle I can make given 3 sides are exactly the same, okay? And so I drag these things around, right? And so this side, it can only be this length. Notice the angles can move, see? It's kind of cool, isn't it? Okay, so the angles can move, but let's see what shape, but the sides can't. So how am I going to make this? How am I going to make this work? What do I have to do? You have to change the angle, change that over there, and boom. Okay. Does this triangle look the same as that triangle?
Yes.
Could I make a different triangle given those 3 sides? I don't think I could. I could try to swing it around and make this over here, and I could swing this around to over here, and I could bring this over here. It would be neat to do this in the. Is that triangle still the same as that triangle?
Yep.
Yes. Okay, so side, side, side is a way to prove that triangles are congruent. So on your conjecture sheet that I gave you on the other day, you see where those are? Side, side, side. Maybe we should wait so that you don't know the answers to all this. Okay, side, side, side. Well, we can try. So side, side, side says if three sides of one triangle are congruent to three sides of another, it's on that conjecture sheet, then the triangles are congruent. And you can have a little picture if you want. View, file, tools, pages. I need this annotate over desktop. So then you could, if you wanted to draw a little picture, you could actually draw this picture. These two triangles. If this is congruent, you could draw this being congruent to that. There's only one triangle. What I usually tell kids to do is I say, if this is true, if this is congruent to that, okay, something like this, just leave it like it is, okay? All right, so if three sides of one triangle are congruent to three sides of another, what can you say about the triangles? Hello, they are congruent. Okay, so that's the first one. Side, side, side. Hey, did I write that? Hey, I wrote that without looking. Okay, so let's see SAS. What do you think about SAS? So, SAS. So let's go to, now I have to go back. Cancel. Uh-oh. Is it not letting me do something? I think I better take a picture of this. Because otherwise, it won't record, like when I record my notes, it won't work. Congruent. Okay? So now I'm going to go to, yes. So now I'm going to go to SAS. And notice it gives me the same side angle side. So in this one, with side angle side, this angle and this angle can't change. Okay? So this triangle, if I move this, notice this thing, that everything moves, okay? But once, so I can change this triangle however I want, okay? So side angle side, you're talking about the side, the angle between this side and another side. So really this one you don't know right here. So there's a side right here, an angle, and then a side. And these three things, this side here, and this angle here, and this side cannot change. So I want to try to make a triangle. Let's see if I can make a triangle. I can adjust this side, right? I can make it shorter or longer. I'm going to come over here and make a triangle. How many different triangles can I make that are different than that? Just one, right? I can just make one triangle, and I can try to drag this. I notice I try to drag this, it won't change, right? And this angle won't change because it's fixed, right? This one's locked there, so it's kind of like this one won't move. So side angle side, side angle side. Notice that the angle must be in between those two sides. Okay, so you might want to draw a picture of that and write this down or fill in the blank on your conjecture sheet. If two sides and the angle between them in one triangle, right? Here's the angle between them. If two sides and the angle between them are congruent to two sides and the angle in between them, then in the other triangle, what can you say about the triangles? What can you say? They're congruent. All right? So that's called side angle side congruent. So you could call up them at the Ford factory and say, hey, I need a triangle just like this, Joe. I need this one to be 10 and I need this one to be 12. And I need the angle between them to be 60 degrees. Okay, that's all you need to know, and then you can make another triangle just like that. Okay, that's side angle side. How about that? What's so funny?
You said 10, but you wrote 8.
Oh, I said 8. Oh, well. Close enough, close enough. All right, so the next one I'm going to talk about is we talked about side angle side. We're not going to talk about ASA yet. Let's talk about is that the next one in this section? I think this is the next one. in this. Well, let's talk about AAA. What do you think about AAA? These three angles cannot change, but the side lengths can change. Do you think, can I make more than one triangle?
Yes.
Watch, okay? So if I drag this triangle around, well, I can't change it, but I can't change the angles, but I can change the lengths. Notice the way those three angles are, if I flip this around and make it correspond to that one, so it's the same, right? This triangle kind of looks the same here, right? This angle goes with this angle goes with this angle goes with this angle. But if I drag this, can I have different size triangles?
Yes.
Yes, okay?
But they're still.
They're not congruent. Someone knows what the word is. What's that word called? Similar, which we talked about. They're the same shape, but they're different size. So if three angles in one triangle are congruent to three angles in another triangle, are the triangles necessarily congruent? Yes or no? No. Okay? So that angle, side is a no. It doesn't work. You understand that? I mean angle, sorry. Angle is a no. Is a no. So you should write that down on your, is there a place on your conjecture sheet? No, because it doesn't work, right? So there's no place. But if you see three angles being congruent to three angles another, then it doesn't necessarily make triangles congruent. Okay, now we're going to look at what Arnold Schwarzenegger says. He says, we're going to look at this AAS now. Except he doesn't say that. He says, get out of my way. What did he say? Did you hear that? Did you ever say, get off the recording because I didn't want to. Yeah, let's look at AAS 1. Okay? So here it is. Press, whoops. AAS 1. So AAS 1, if two angles in a side not between them in one triangle are congruent to two angles in a corresponding side not between them in another triangle, what can you say about the two triangles? Okay? So in other words, in this one, this angle, and this side. So this angle has to match this angle has to match this angle, and this side has to match this side. That's called AAS. Something you could call it in reverse, SAA. Okay? So let's look and see if it works. Is there more than one triangle that I could make here?
Yes.
There is? Where? Let's see. I can drag
Could you
this.
extend that line in between the two angles?
Extend what line?
In between the two.
This one right here?
Oh wait, never mind.
I could, but it won't make a triangle. See?
Oh,
It won't make the same triangle. Okay? What?
Can you move?
I can move the E out.
yeah.
Okay?
No, you can't. Because
It's fixed. Angle, side is fixed, right? This angle, this side have to be fixed. So angle, side, how many different triangles can I make using that? How many different triangles can I make? Using an angle, and a side.
One.
Exactly one. So angle, side, as long as it goes angle, then side, and angle, then side, is a way to prove that triangles are congruent. So angle, side, you would say if two angles and a side not between them in one and congruent to two angles at the corresponding side, okay? And we'll talk more about corresponding, not between them. What can you say about the triangles? What can you say about the triangles? They're congruent, okay? Congruent, like that. Okay, I'm going to take a picture of this so that if it goes in my notes, so that people can see it in my notes. All right, there we go. Okay, congruent. There you go. Okay, let's go back to the next one. Now we're going to talk about angle, side 2. Good. That's like Terminator 2. You know? No, angle, side 2 says the broken has two angles and a side not between them, congruent to two angles and a side not between them. Okay? So notice here it's a little bit different. I have an angle, and the side matching up with this angle, and this side. So notice it goes green, then blue, then side, right? Here it goes blue, then green, then side. You understand the difference between this and the last one? In the last one, this, it goes angle, then side. In this one, it goes angle, then side, but they're not corresponding, meaning this side does not match up with this side. Is there more than one triangle I can make? I think, yes, there is, I think. Watch. See this? I can drag this over here. I can, oops, watch this. Is this triangle exactly the same shape as this triangle? No. Watch. So what I have here is this angle here, right, is congruent to this angle here, which is okay. This angle here is congruent to this angle here. But this side here, rather than being over here, it's over here. So the correspondence doesn't line up. You know what I mean? Okay? So angle side 2 works only if angle side only works if you go in the correct corresponding parts. Okay? So for angle side to guarantee congruent triangles, what's meant to be true about the corresponding sides? They must be congruent. Okay? So this angle side 2 does not work because this is not corresponding to this. All right? Hey, you had your cell phone that you were playing on with? Yeah, you were. Here, just give it to me. You're not allowed to have it. Yeah, okay. I'll text her and tell her you're not allowed to have a cell phone. All right. So, all right. So, anyway, let's move. So we've done this side, side, side. Have we done side, angle, side?
Yep.
Yes. Did we do angle, side, angle?
Yep.
We did?
Yeah.
No, we didn't.
Yeah, it is.
No, we didn't. Okay. So I'm gonna look at that one now. So let's look at angle, side angle, which means that you have an angle and a side between them, and another in one triangle are congruent to two angles and a side between them. So notice this angle goes with this angle, this side goes with this side, and this angle goes with this angle. Can I make more than one triangle?
No.
Let's try. Can I make more than one triangle given those parts? No, just one. So angle, side angle works. So this is a picture of angle, side, angle, angle, side, angle. And so they are congruent. It's a little complicated, but we'll go over these. Congruent. I really think you should be writing these down on your conjecture sheet. This is kind of the meat of the chapter. Okay? And you really, really have to know this. Otherwise, you're going to not do very well when it comes to learning it. So I'm going to take a picture of this again just because I want you to, all right, okay? So I think we've talked about everything except for the bad word spelled backwards, right? Have we talked about everything except for side, side, angle?
What about angle, side, side?
What? No, this stuff's not going to be on the quiz.
We're gonna do side, angle, angle.
Side. I talked about this, I talked about this, I talked about this, talked about this, talked about this, I talked about this, I haven't talked about side, side, angle. So let's look at side, side, angle. So, what the heck? Side, side, angle. Oh, I was playing with it in the other class, okay? So look, side, side angle says if two sides in an angle not between them in one triangle are congruent to two sides and the corresponding angle not between them in another triangle, are the triangles congruent? So in this case, this side is congruent to this side is congruent to this side, and angle B is congruent to angle E over here. See that? So you say, hey Joe, make me a triangle. And you say, I want this side to be 10 meters long. I want this side to be 12 meters long. I want this angle to be 30 degrees. Can you ensure that he's going to send you exactly the same triangle? I don't know. Let's see. Okay? So first of all, I can make this triangle right here. I could extend this side. Okay? Does this triangle look like this triangle?
No.
Not exactly, right? Because I could take this side, I could take over here, and I can make another triangle with the same two sides and this angle. Do you understand that? Okay? So this side, and then that angle. This side, and then that angle. But this triangle, if I make this an obtuse or a bigger triangle right there, okay, then this triangle is not congruent to that triangle. So side-side angle, not only because it spells a bad word, but also because it doesn't work. Okay, side-side angle, you can make two different triangles with side-side angle. Okay, so side-side angle does not work. Okay, no sir, no sir, you say. So side-side angle does not work. Okay, side-side angle, no. Bad. So if you teach two sides and angle, then you say it does work. All right. So now I'm going to take a picture of this, and then I'm going to show you some examples of the types of things you're going to see. Okay. And tonight, I think you're just working on side angle, side, and side angle. But let's look, for example, at something that looks like this. And things that I draw are not necessarily to scale. Okay? So I'm going to draw a triangle that looks like this, that looks like this, and this. And then I'm going to draw, I'm not going to use my triangle tool, use my line tool. Go like this, and I'm going to say that this is congruent to this, and this is congruent to this. And I'm going to just call this triangle 1 and triangle 2. Is triangle 1 congruent to triangle 2? And then you're going to say why or why not. What do you think?
Yes. It's possible.
Yes.
This is the kind of stuff you're going to see in your homework. Yes or no?
Yes.
Why?
Flip it over like this.
Yeah, but you have to use one of those properties. And the properties that I know are either side, side angle, side, angle, side, angle, angle, side, or
Side.
where's the other side?
The middle.
Okay, very good. So there's another side here that you have to kind of pick up the slack a little bit. You have to say, oh, that side's in both triangles, right? Therefore, by side, those two triangles are congruent. Get that? Okay, so that is why side, yes, by side. Okay? I can do a couple more. I know you know. So let's look at, here's another one. Say I have a picture, which you will, that looks something like, I'm just going to draw it with my line tools. Draw this, this goes to here, and this goes to here, this goes to here. And all I'm going to say is this and this are parallel, and they're also congruent. Okay? A, B, C, D. And they will say something like, is triangle A, B, D congruent to triangle C, D, triangle C, D, B? What do you think? Yes, no, why, maybe, yes. What do you think? Yes, sir.
I think three. Yes, it is correct.
Why?
Because they share that one side,
Okay.
and then
Oh, I want you to be taking notes.
since they're parallel, that means that the angle at B and D I'm not.
Very nice.
We're the same.
Okay, so what Garrett just said, and he's right with it, okay? He said, you know they share this side, right? So far you have a side and a side. And he also said because this means parallel, that must mean that these two angles, because those are alternate interior angles, are congruent. See that? So side, side, angle between them, and then side. See? So that's yes, by side, angle, side. And you might, like when you do a proof, you're going to have to say, well, I know these angles are congruent because those are parallel lines. I know that this is equal to itself. I'm given that these two are congruent. Therefore, those two triangles are congruent by side, angle, side. Yeah? Okay. I'm going to do a few more examples. So, because these can get tricky. So here's another picture you're going to see. And this is what I'm going to tell you, that this angle is congruent to this angle down here. And this angle is congruent to this angle over here. Are these triangles congruent, this one and this one? Why or why not? What would it be if I did?
You have to have one side the same way.
You have to have one side the same. What do I have? Okay?
Three angles.
How about these two angles? Are these the same?
Yeah.
Yeah, those are called vertical angles, so those are congruent. Okay? And so, are these angle, angle, angle? Is that a way to prove triangles congruent?
So,
Okay? No, doesn't work. See? So in some cases it works, in some cases it doesn't work. Let's do one more, and then we could do a couple more. Okay, can you put that away, please?
Okay.
Okay?